Good morning, grade 9 students. It's me, Sir Doms. And today we will discuss another new topic, and it's about electromagnetic radiation. For our intention competency, describe electromagnetic radiation or EMR as energy that is created by the vibrations of electrically charged particles, which allows it to travel through materials or space as transverse waves. These are our objectives. At the end of the lesson, the students should be able to first, identify and describe the origin of electromagnetic radiation or EMR. Second, differentiate EMR from the mechanical waves. And lastly, trace and explain real-world applications of EMR. Think about it. Have you ever wondered how your food heats up in a microwave without any fire? Or how your smartphone catches a signal out of thin air so you can chat with your friends? And how can you use a remote control to change TV channels without touching the television? Today, we are going to unlock the secret behind this invisible radiation that rules our modern world. Are you ready? For our learning experience, we will have an activity titled The Slinky Wave. For our materials, we will use slinky toy and ribbon. So first, tie a ribbon in the middle part of the slinky toy. Then, hold it on both ends for at least 2 meters apart. For task 1, on one end of the slinky toy, move it back and forth. Observe the direction of the wave and the movement of the ribbon. So this is the video. So as you move your hand back and forth, observe the movement of the ribbon. So it moves back and forth as well. And the direction of the wave is from the hand to the other end. And now for our guide questions. Number 1, what is the source of energy of the wave? Second, how did the ribbon move? Third, compare the direction of the movement of ribbon to the direction of the wave. Okay, so let's check your answer. Number 1, the source of the energy of the wave is the hand. So the hand provides the energy. It oscillates or it keeps moving back and forth. Second, as the wave passed by, the ribbon moved back and forth. And lastly, the movement of the ribbon is the same as the direction of the wave. So if they have the same direction, we can say that they are parallel. So the movement of the ribbon is parallel to the direction of the wave. And for our task 2, this time on one end of the stinky toy, move it up and down. Observe the direction of the wave and movement of the ribbon. So this time, the movement of the hand is up and down. So guide questions. Number 1, what is the source of the energy of the wave? Second, how did the ribbon move as the wave passed by? And number 3, compare the direction of the movement of ribbon to the direction of the wave. So let's check your answer. Number 1, the source of the energy of the wave is the hand. Second, as the wave passed by, the ribbon moved up and down. Okay. Number 3, the movement of the ribbon is perpendicular to the direction of the wave. Perpendicular means that they intersect at 90 degrees. So as you can see from the video, the movement of the ribbon is up and down. It intersects to the direction of the wave. So for task 1, it is a demonstration of the longitudinal wave. And for the second task, it is a demonstration of transverse wave. So as you can see, in longitudinal wave, the movement is compression and decompression, or what we call rarefaction. So as the compression travels, it compresses the materials that it passes through. So look at the red line. So it keeps moving back and forth. And transverse wave, on the other hand, the movement of the red dot is up and down. So the direction is perpendicular. Here's a table of the difference between longitudinal and transverse wave. So for particle motion, the longitudinal wave is parallel, meaning they have the same direction. And in transverse wave, the particle motion is perpendicular. It means that they form 90-degree intersection. Next example of longitudinal wave is sound wave. Also another example is seismic wave or earthquake. Next is in transverse wave, example is light. So the light that comes from the sun is an example of a transverse wave. And another example is rope. And for medium, when we say medium, it is used by the wave so it can travel. So for longitudinal wave, it needs medium. So when a wave needs a medium to travel, we call it mechanical wave. And for transverse wave, the medium is not required or it doesn't need medium. For example is electromagnetic radiation. Okay? So it means that even though there's no air, there's no anything, it can travel. So that is our topic today. So we will focus now about electromagnetic. Electromagnetic radiation travels as transverse waves. Electromagnetic radiation moves as transverse waves. In a transverse wave, particles move up and down while the wave moves forward. So what is electromagnetic radiation? Electromagnetic radiation is a form of energy produced by the vibration or acceleration of electrically charged particles. These vibrations create electric and magnetic fields that move outward together. So it is called electromagnetic because it is a combination of electric and magnetic field. So this is the illustration of electromagnetic radiation. So the symbol for electric field is E, capital E, and magnetic field is B. They oscillate at right angle to each other. Oscillate means that it is moving rapidly and repeatedly. Both E and B are perpendicular to the direction of wave travel. And these waves can travel through vacuum at the speed of light, or C equals 3.0 times 10 raised to 8 meter per second. So imagine the speed of electromagnetic radiation. It is so fast. In a blink of an eye, it can go through far distance. How does electromagnetic radiation travel? So unlike sound waves, electromagnetic waves do not need a medium like air, water, or solids. They can travel through vacuum or empty space. Like in outer space, it's actually a vacuum. Air, it can also travel through water, glass, and other materials. So this explains why sunlight can travel from the sun to earth through the outer space. So the characteristics of electromagnetic radiation includes: number 1, it carries energy. Second, it travels at the speed of light in a vacuum. So it's very fast. So again, the speed is 3 times 10 raised to 8 meter per second. And then it doesn't need a medium. It behaves as a transverse wave and is produced by vibrating electrically charged particles. So the application of electromagnetic radiation includes: radar uses transmitted radio waves to detect objects and determine their exact distance, size, and speed. Radio uses electromagnetic waves to transmit information, sound, or data through the air. So who among you still likes to listen from radio? Next, Wi-Fi. Wi-Fi allows your devices, such as your phone, your laptops, and sometimes our TV, to communicate wirelessly with a router for internet access without using cellular data. So right now, Wi-Fi is very important for us. Next, remote. It is used in controlling a device, network, or application from a distance using infrared radiation. Microwave oven uses electromagnetic waves to heat water molecules in food through rapid vibration, generating heat via friction. So who among you heats their food using microwave oven? X-ray utilizes electromagnetic radiation and is widely used across medicine, industry, and science for imaging, therapy, and analysis. Next is the sunlight. So every day we see sunlight. Sunlight is actually an example of electromagnetic radiation that provides energy for plants to produce their own food. For another activity, on your notebooks, think of your daily routine. Choose one gadget or appliance that uses electromagnetic radiation. And then answer the following question. Number 1, what gadget did you choose? Second, what type of electromagnetic radiation does it use? And lastly, how does electromagnetic radiation help the gadget function? So there are possible answers for number 1. First, you may write cell phone, Wi-Fi router, TV, remote, and microwave oven. So number 2, what type of electromagnetic radiation does it use? So mostly utilize electromagnetic radiation like radio waves and microwave. And lastly, the function of electromagnetic radiation to these gadgets or appliances is that these waves carry signals that allow communication. And now let's wrap up our learnings. First, electromagnetic radiation is a form of energy produced by vibrating electrically charged particles. Next, it travels through materials and even empty space without needing a medium. Electromagnetic radiation moves as transverse waves composed of electric and magnetic fields that are perpendicular to each other. Next, because of electromagnetic radiation, we can enjoy sunlight, communicate using cell phones, connect to Wi-Fi, and use many modern technologies. And now for our assessment, get your notebooks and your pen and answer these questions. Number 1, what triggers or creates electromagnetic radiation? A. The vibrations of electrically charged particles. B. Moving chunks of rock. C. Extreme sound levels. Or D. Throwing something on water. Number 2. Which type of wave best describes how electromagnetic radiation travels? A. Longitudinal wave. B. Sound wave. C. Transverse wave. Or D. Seismic wave. Number 3. Unlike sound waves, electromagnetic waves can travel through which of the following? A. Only solid steel. B. Only gas or air. C. Only liquid water. Or D. A complete vacuum or empty space. Number 4. In a transverse wave like EMR, how do the vibrations move relative to the direction of the wave? A. In the exact same direction. B. Backward only. C. Perpendicular or at the right angle to the direction of travel. Or D. In opposite direction. Number 5. Which of the following is a real-world example of EMR traveling through empty space to reach Earth? A. Ocean waves hitting the shore. B. Sunlight reaching the Earth. C. The sound of an explosion in space. Or D. Vibrations caused by earthquake. And now it's time to check your answers. Number 1, the correct answer is letter A, the vibrations of electrically charged particles. So this is the source of electromagnetic radiation. Number 2, correct answer is C. It is transverse wave. Number 3, correct answer is letter D, a complete vacuum or empty space. So mechanical wave cannot travel through vacuum. Next, number 4, correct answer is letter C, perpendicular or at a right angle to the direction of travel. And lastly, number 5, correct answer is letter B, sunlight reaching the Earth. How did you do, class? Did you get a perfect score? Congratulations on finishing this lesson. And now for ways forward. List 5 objects or technologies that use electromagnetic radiation. For each object, write first the object, next the type of electromagnetic radiation it uses, if known, and how it helps people in everyday life. See you next lesson. Remember, electromagnetic radiation travels through space without giving up. Let it remind you to keep moving toward your dreams, even when the path seems empty. Thank you for your support. Please like and subscribe to Sir Dom's blog. Goodbye!